Welcome to this demonstration of solutions in EcoStruxure Control Expert to implement EthernetIP explicit messaging with the function blocks offered in the general purpose library. Please bear in mind that this is a basic demonstration not intended to replace any formal product training. The user might also need to adapt the configuration shown to the actual project requirements. This presentation is structured in 3 chapters, each one starting at the time indicating on the slide. You might have also viewed another video I prepared for configuring EthernetIP explicit messaging with the data exchange function block. In this case, you can skip the first introduction chapter, which is identical in this other video. Before we begin the demonstration, let's briefly discuss when explicit messaging could be required or could be useful for your projects. As reference information, this is a network layout of the equipment configured for the purpose of this demonstration. Communication between an M580 EPAC and a T-SysT motor controller is configured for EthernetIP protocol with implicit messaging through the use of an EDS file and its associated DTM object. However, additional information from a field device, including drives, robot controllers, or the T-SysT unit of our example, is only available through explicit messaging. This is the case of some diagnostic information or data to identify the device, such as its MAC address. We might also want to identify the CPU and the NOC modules in this M580 PLC, specifically with their MAC address and firmware version. So, to remotely identify the CPU and NOC modules via the supervision network, explicit messaging will help us to make this data available in the PLC's registers, even when the NOC module connected to the supervision network does not have its communication enabled with the Ethernet bus of the backplane. For your reference as well, the software and firmware versions successfully tested for this demonstration are listed on this slide. So if we take a look at the sample program that I prepared for the demonstration, you'll notice that this is an M580 PLC in which the processor, the CPU, has a DTM object used to scan data or to obtain data from a T-SysT motor controller using implicit EthernetIP messaging. You'll see that we are getting data in real time, and this has been done by using a DTM produced by the act of importing an EDS file that has a series of assemblies available with predefined registers. You can actually select when you add a connection which of those assemblies you would prefer to use. Now, in some cases, you might require some additional information that is not necessarily available through these predefined assemblies for EthernetIP. For example, we could take a look at the manual for the T-SysT motor protection unit, and you'll notice that there is information that is arranged in an object dictionary with information that can be available using EthernetIP explicit messaging. This additional information is grouped using different class codes. So one of the first parameters that you might need to know to find this information or to address appropriately these registers is finding out in which class code the information can be found. So if we further look into one example, in the case of the T-SysT of one of the class codes, we have the Ethernet link object, which is identified with hexadecimal F6 class code. Within this class code, there are up to 2 instances, number 1 and number 2, which are 2 identical groups of data, each one containing this series of attributes. And in our case, what we'll be interested in looking for is the MAC address, which is identified with the attribute of hexadecimal value 3. Another interesting example is the firmware version of the T-SysT device, as well as diagnostic error codes or the number of messages exchanged with the device. Having this capability of detecting the MAC address or the firmware of a field device could be helpful to generate an alert if there has been an unauthorized replacement of the device. This could also help to improve the management of the assets in the control system. Going back to our PLC configuration, it also happens that the CPU and the NOC modules in the M580 controller have the same type of object dictionary. This could be extremely useful to remotely access the identity information of the processor or other modules on the PLC backplane that may not be directly connected to the supervision network. This is precisely the case in my sample project, where we assume that the NOC module is connected to the external SCADA system, but the connection to the Ethernet bus on the backplane is disabled. In this scenario, since the NOC301 module is isolated from the Ethernet network of the CPU, it will not be possible to remotely view the embedded web page of the CPU or connect online to its DTM to find out what is the MAC address or its firmware version. However, if we use the explicit communication function blocks within the PLC logic, it will be able to access this information, then make it available as PLC registers that can be accessed by the SCADA system through the data dictionary or localized memory words. One important detail to consider when using explicit messaging is that there is a maximum number of communication function blocks that can be simultaneously active at any given time, and this includes the sum of all types of explicit messaging, including Ethernet, such as Modbus TCP or EthernetIP, as well as CAN open or Modbus serial communication. This means that you might need to add some logic in the PLC program to control how many and when the function blocks are triggered, and perhaps even monitor an activity bit before triggering additional function blocks and then avoid exceeding the communication buffer of the CPU. Furthermore, the maximum number of simultaneous explicit messaging function blocks is documented in the user guides for each one of the processors and Ethernet communication modules. In the case of the M580 CPUs, it varies from 16 to 96, depending on the CPU model. Then in the case of the BME NOC 301 or 311 modules, the maximum number is 16. It is also the case for the BME NOC 321 module, maximum number of 16. And then we have the BMX NOC 0401 module used for the M340 PLC, also with a maximum of 16 simultaneous requests shared between Modbus TCP and EthernetIP. Two solutions are available to implement EthernetIP explicit messaging. One of them is by the use of the data exchange function block. As I mentioned before, there is a bit related to the activity or the status of the function block. In this example that I'm showing on the screen, it is being used to make sure that the operation or the transaction of the data exchange function block has been finished before triggering it again. Secondly, when using the data exchange function block, there's a very important structure that is connected to the very bottom pin. Here's where we will manage parameters such as the timeout for the communications of the function block, and every time it's going to be triggered or initialized, we need to move a value into one of the words of that array or structure, indicating the number of words that's going to be sent out the query of the data exchange function block. Lastly, through another structure connected to one of the input pins of the data exchange function block, here's where we're going to be able to enter the values of the class, instance, and attribute that are going to be used to find the information within the object dictionary of the device. As for the use of the general purpose library, when using EthernetIP explicit messaging, you basically combine two types of function blocks. One of them is the client profile function block, for which typically you would have one instance for each memory location for each type of query with its class, instance, and attribute parameters. And then all of these instances of client function blocks are going to be connected through a work memory variable, and all communications leaving the communication port are going to be managed by a single port profile function block, which is managing the number of simultaneous queries active at a given time. So if we compare these two methods side by side, in the first case for the data exchange function block, you will notice that the communication parameters, such as class, instance, and attribute, must be passed on to an array following a very specific syntax, and this will be done through the fourth input pin with the data to send array of the data exchange function block. Secondly, the user must manage the number of simultaneous queries that are being sent out the communication port, so there might be additional logic that the PLC programmer has to include to control the way in that these data exchange function blocks are being triggered. Thirdly, the data exchange function block does not include any integrated statistics, such as indicating the number of messages that have been successful or with errors, or the average time spent during the communication. In that case, the PLC programmer could add some logic to calculate these statistics, based on communication reports, error codes, the activity bit, or transaction numbers. One advantage, though, is that there is a much smaller memory requirement when we compare it to the implementation of explicit messaging using the function blocks of the GPL. As for the GPL function block, one big advantage is that the communication parameters are entered directly as values in 4 of the inputs, such as the service ID, class, instance, and attribute. Also, there is a port profile function block that is going to take on the responsibility of managing how many simultaneous queries are being sent out the communication port, so there's less of a need of custom logic to be added to control how the function blocks are being triggered. There's also an additional function block available that calculates the statistics related to the use of each one of the client function blocks, and there's no need for the user to then calculate how many messages have been successful or with errors, or the average time to send out the messages. One detail to look out for, however, is that using the GPL function blocks is going to create some large structures in the program memory, so you might want to check the free space available in the processor as you develop